Welcome and many thanks to the organizers for putting this paper on the program. It is titled The Extensive and Intensive Margin of Price Adjustment to Cost Shocks. And as always, the central bank disclaimer applies, so the views expressed here do not necessarily reflect the views of either the European Central Bank or the Danish Central Bank. So what we're doing in this project is, what we're doing in this project is we're estimating a dynamic pass-through or a dynamic path of price adjustment to commodity input cost shocks. And we're doing so using very detailed microdata underlying the Danish PPI survey, which we augment by merging it to a relatively rich set of firm-level data on cost. And then what we introduce in the estimation of this pass-through is features that are common to many macroeconomic models, most prominently nominal rigidity. So be it some kind of Calvo price setting or state-dependent price setting models, we need to distinguish between an extensive margin of adjustment to shocks and an intensive margin, so by how much we're going to adjust prices. And the second feature is that firms are not price takers or not perfect price takers. So we can account when setting up our methodology for the estimation, we can account for these strategic complementarities between firms' pricing decisions. Microevidence of this type is important for several reasons. I just want to name two of them. So first of all, central banks want to understand the dynamics of aggregate inflation. So microevidence on how firms do this sort of price adjustment, for example, to an oil supply shock, an increase in the oil price, will help us understand how this transmits to aggregate inflation rates. And then we want to inform the debate on state-dependent price setting. For example, just to make an example, if you have some state-dependent menu cost model and you have a large shock in this model, then the firms will select into immediately adjusting the price to the new optimal price if they're outside of the inaction region. And there will be low real effects of monetary policy. But it has been shown that if firms are multi-product firms and synchronize prices, then we're going to have a larger mass of small price changes if they synchronize the price changes of their different products. That's something that we're going to use in this project, and where we can achieve larger real effects of nominal shocks in the models. So let me give you a preview of the results. We do indeed find some state dependence in response to cost shocks. So firms change the probability of increasing or decreasing prices when they receive changes in their cost. We also find evidence of price synchronization within firms, so that firms tend to, if they have multiple products, they tend to adjust several prices at once rather than one price at a time. And we're going to indeed use this finding in order to set up our estimation methodology. I'm going to talk about this at length. When it comes to the actual pass-through along the intensive margin, so by how much firms pass on increases in cost, we find that despite the state dependence that I talked about, the selection bias this introduces is rather small. It is statistically significant, but economically small. In terms of the estimated pass-through, we find quite large degrees of heterogeneity. We're going to look at two different types of input cost. The first is a shock to the price of oil or to the price of energy the firm produces its goods with. And there we find the response to be rather delayed. So it's a slow kind of adjustment. And we find evidence of a sectoral pipeline effect, so that some sectors adjust earlier than others. For the second shock we looked at, which is a cost to the price of imports, we find that the pass-through is very much incomplete. So if a single firm receives an increase in the cost of its imported inputs, then it only passes a relatively small fraction of this onto its customers, and the rest is absorbed by the markups. And finally, we have some results on strategic complementarity. So we really do see in the data that firms respond to each other's pricing decisions. Right. So let's start with adjustment under flexible prices. We start simply with the observation that the optimal price we would like to set, P star, is a markup mu over marginal cost. Now, under some fairly general assumptions, markups are a function of the firm's own marginal cost and of the prices of competitors, which we denote here P bar of all the other firms, so minus J in the subscript. If we take this observation and we write the first equation in first differences, we get an equation that we can, in principle, estimate, where we have on the left-hand side the change in the price, and on the right-hand side we have the change of some observable component of marginal cost and the change of the price of competitors. The estimated pass-through coefficient would be the 1 over 1 plus gamma, and if this is estimated to be 1, then the pass-through is complete, and if it's lower than 1, it implies that the markups absorb some of the changes in marginal cost. So if we simply had flexible prices, we could estimate this pass-through equation 1. However, in reality, prices are not flexible. Prices are very much sticky. The figure that you see here is taken from our data underlying the Danish PPI. And it takes the data at a given point in time, month 0, and it looks at the unconditional frequencies of price changes at this point in time. So if we take month 0, we see that the combined probability of decreasing the price here in blue or increasing the price in red is combined 19%, and all the white region is in action, where prices are unchanged. Now, as we move on in time, we can see that the white area, the inaction, decreases, but it's still very large. Even 2 years after observing the price for the first time, we still have a 20% chance that the price is unchanged. So there's a lot of stickiness in the data, which means that we need to account for this when estimating the pass-through. Now, why is this problematic? If we estimate the pass-through equation I showed you 2 slides ago, and we keep all the 0 price changes on the left-hand side in the regression, but we have changes of marginal cost on the right-hand side, we're going to confound some of the stickiness in the data with the actual structural pass-through elasticity. And we're going to, in fact, underestimate the pass-through coefficient. This is illustrated here in the picture. If we receive, as a firm, we receive a positive marginal cost shock, but we keep the 0 price changes due to the stickiness in the data, then we're going to underestimate the structural pass-through, which, if we didn't observe any stickiness, would go up directly and then stay where it is. This can be addressed, for example, by simply dropping all the 0 price changes from the sample. But this is problematic because it can create an endogenous selection bias if there is some state dependence with respect to the received cost shocks. And to imagine this, take the example of a menu cost model where a firm can receive 2 different types of cost shocks, one of which we observe and the other one which we do not observe. Now, if a firm receives both of those costs, for both of those costs, it receives a positive shock. That means the chance that it's far away from the optimal price and therefore adjusts the price to the new optimal price is higher if the two shocks have the same sign, which means that it's more likely to be included in the sample with the non-zero price changes. And this is all relative to a firm that receives two different cost shocks of the opposite sign. So if we do not observe all the cost shocks, all the costs, and there is some state dependence, we would in fact overestimate the structural pass-through if we just throw away all the zero price changes. I note that this notion of price synchronization within firm can weaken this selection effect somewhat, and this is indeed the direction in which our paper is going. But you will see later more about this. So what we do to address this problem is we develop a new estimation methodology in the style of a Heckman selection correction. So we have two steps in our estimation methodology. The first step is a multinomial logit model, where the firm's decision is modeled as it can increase or decrease the price or keep it unchanged based on some observables Z. The Z includes the shocks that we observe and more variables that I will talk about later. In the second step, is estimated with OLS based on the sample excluding the zero price changes, but we augment this regression with a transformation of the probabilities that are estimated in the first step. So it's a result from Bourguignon et al. That you can write, if the first step is a multinomial logit model, you can make this selection bias correction here on the bottom right based on some transformation of the probabilities from the first step. Already now, I should note that the first step is based on the regressors of the covariates X, which are not exactly the same as the covariates in the first step Z, but I will talk more about that in a second. So I think this would be a good moment to get some questions if there are any.
No questions so far, so we can continue.
Great, then I will just move on. So we implement this approach, as I said, on the microdata underlying the Danish PPI. We used a sample from 2008 to 2017, which contains roughly 940, mostly manufacturing firms and more than 5,000 commodities. A nice feature of this data is that we have relatively long uninterrupted spells where we actually observe the price quotes. So this really allows us to track price setting decisions at a very granular level of those firms. And we link this data to a rich set of firm level cost information. For example, purchases from VAT filings or also monthly payrolls for those firms. Now, the marginal cost, we're interested in those two shocks in a change in the energy cost to the firm and import cost, and we're going to measure them as follows. We're going to take an interaction of the share of energy in the firm's cost structure, so this would be the phi E lagged. This is a firm level energy share, which on average, which we take from the data because the firms report it, and on average, this share is 1.8%. And we're going to interact it with the change in the aggregate price of energy. So with the change in the aggregate price of energy, we might be concerned of some endogeneity, because the change in the price of energy responds to local demand in Denmark, responds to local demand conditions, which of course also matter for price setting decisions. So what we do is we take a projection of this price of energy, delta PE, on the series of oil supply shocks from Baumeister and Hamilton, and we find that indeed a positive oil supply shock, according to this Baumeister and Hamilton series, leads to not only a negative effect on the price of oil, but also somewhat smaller on the index for price of energy in Denmark, which includes not only oil, but also electricity, heating, and so on. So what we do is we take this Baumeister-Hamilton measure and we scale it to have the size of a positive 1% shock on energy, instead of doing a proper instrumental variable, because we have this two-step procedure which already makes things complicated enough. Right, and then we do something similar for the imports, where we interact the share of imports, which we know from VAT data and is on average 26%, with the change in import prices, which are observable in the PPI wave and in the import wave of the same PPI data that we have. So this import price change is very much firm level. So the firm actually reports the change in cost of its own imports, whereas the energy measure is more common across firms, and you should keep this in mind as we move on to the results. So apart from those two shocks, we control for the change in prices of competitors, as argued before, and then we control for all possible costs that we can observe from the firm, and some aggregate controls like the CPI or the exchange rate. And then we do this in local projections. So the right-hand side of the regression always stays the same, but on the left-hand side, we vary. We take the cumulative price change of the good between the period of the shock and some period t plus h, which varies from 0 to 24, to get a dynamic estimate of this pass-through. This two-step estimation procedure needs some help to identify what is the extensive and what is the intensive margin of price adjustment. And to that end, we exclude some of the covariates, or we include some of the covariance in the first step, but exclude it from the second step. And examples of this include a month dummy, because there is strong seasonality in the frequency of adjustment, but not in the size of adjustment. We also take the standard deviation historically of price changes within the firm. And then most importantly, we build on some results from the literature on price synchronization, which says that if a firm has, let's say, 5 products and it increases the price of 4 of those, then it's also more likely to increase the price of the 5th at the same time. And this is indeed what you can see here for different estimation horizons. So if the bullets show you that if the fraction of all the other goods within the firm show a price increase, then the remaining good is also more likely to increase the price, and it even works with decreases. So if all the other goods within the firm see a price decrease, then we're also more likely to increase the price. So this is a feature that we can use to distinguish between the extensive and the intensive margin.
Excuse me.
So, yep.
We have a clarifying question from Stefan Smith. Yes. Do you know how much the firm has to pay for its energy costs, similar to the details you have on prices for goods sold by the firm?
I'm not sure. Can you repeat it? Or?
Yes. Do you know how much the firm has to pay for its energy costs, similar to the details you have on prices for goods sold by the firm?
Unfortunately not. So what we see is a kind of a revenue statement for each year of the firm, and then it reports how much, how high is the cost on energy, but we do not see what kind of energy or at what point in time or which good exactly is which energy good is purchased. Yeah. Okay, there is some. So this is the evidence on state-dependent price setting. So if you take, for example, 12 months after the cost shock, after receiving a 1% cost shock to energy, then the probability of having increased the price is 4 percentage points higher than to comparable firms. For imports, this is somewhat lower, but again, imports is very much an idiosyncratic shock to the single firm. So if the price of imports goes up by 1%, then the likelihood of increasing the price is 1 percentage point higher. And interestingly, for an aggregate measure such as CPI, if the CPI goes up by 1%, then the single firm is more likely to increase its price by 12 percentage points. So this is the evidence on state dependence. I was going to ask for more clarifying questions at this point. If there are any?
No, I will let you know if there is another one.
Perfect. Then I'll move on. So having presented the extensive margin results, we're moving on to the intensive margin. And I just quickly want to show you how these two shocks actually look like. So what you see here is basically future realizations of this share price change interaction regressed on the shock itself, just to show you that it essentially looks like a random walk. So the shock we're looking at increases the price of the cost the firm pays on energy by 1, and then essentially stays there. We should also note, though, again, this relatively large common component of all these cost shocks, and that we cannot exclude the fact that there are some general equilibrium effects, because we're talking about a supply shock which affects the entire economy. So there might be some effects on wages or other variable cost that we do not control for later on in the medium run. So in terms of how firms adjust in response to this shock, you can see the following results emerge. You can see in this figure 3 different estimates. The one we propose for our selection bias corrected methodology, and then the OLS excluding zeros and including zeros. So you see that in all 3 estimation methodologies, the adjustment is rather slow. And this is independent of nominal rigidities. So the OLS excluding zeros is a little higher than the dashed line including the zeros, but it doesn't seem to be economically large. However, we can directly test whether the correction turns that we have in our regression are statistically significant. This is what is shown here for 2 estimation horizons, and they indeed are. So there is, if you draw a positive cost shock, you are more likely to select yourself into increasing the price. Due to the rich nature of our data set, we can look at some heterogeneity and try to uncover some interesting findings. So the first split we do is we look at intermediate goods versus final goods. And this is what you see here in the red line. On the top left, you see that the pass-through for intermediate goods is considerably faster. You see a significant effect on impact, as opposed to final goods especially, which are estimated with quite a lot of imprecision. But interestingly, when you divide the sample into high and low oil exposure, there is a very clear evidence of some pipeline effect. So what we do is we look at input-output tables, and we look at the different sectors, which sector is close to the oil sector and which sector is relatively far away from the oil sector. Then we split the sample and we repeat the exercise for both of those samples. So for sectors close to the oil economy, the pass-through is much faster, although we still have a somewhat delayed response. But for the low oil exposure sectors, we see that they do not react for at least 12 months and that the pass-through only happens later on. So this is some evidence for some that positions in production networks matter for our understanding of this adjustment.
Sorry, Gabriel, you have 5 minutes.
Yeah, perfect. So for the second shock we look at, for the import cost shock, we see that we again regress future realizations of the cost of this share price interaction on the shock, and we can see that also this is fairly persistent, and this is now really a specific shock that only the single firm receives. Right. If we estimate the pass-through to prices on this one, we can see that the pass-through is much lower, so it's very much incomplete regardless of which methodology we use, whether our selection bias correction or a simple OLS. The estimated pass-through on impact is maybe about 0.3, which means that a large fraction of cost changes are absorbed by markups. Now, the pass-through is also much faster, and even there, nominal rigidities play a relatively small role. So if you compare the OLS excluding and including zeros, and you compare it to what you would expect from a Calvo model with a 19% adjustment probability, then you would assume this dashed line, including the zeros, to be much lower. But we see that even the one including zeros does react on impact, and by about half as much as our selection corrected. Also here, some interesting heterogeneity. We split the sample here into small and large firms, so firms with less than 50 employees, where you can see that the pass-through in red is much larger than for firms with 250 employees or more. So that's one finding. And the other finding is really about these strategic complementarities. So we can see that when a large firm increases the price due to an idiosyncratic cost increase, then its competitors use this fact to increase their prices themselves by only marginally, but there is a significant response, even though they haven't received that cost shock. So we really see these interaction between competitors. All right, so I think my time is coming to an end. Let me just conclude. So we see evidence for synchronization of price setting within firms and significant state dependence in adjustment to cost shocks of firms. And then we developed this two-step framework to estimate the path through of these cost shocks, correcting for selection bias. And the findings there is that selection is statistically significant, but economically small. The path through of an innovation to this common energy price is delayed, and this is independent of nominal rigidities. and adjustment to a much more firm-specific shock to import cost is faster but incomplete, such that markups absorb a large part, especially in larger firms. This from part, and now I'm handing over to the discussant.